Good morning, good afternoon, and good evening. This video is going to be a follow-up to video number 32, where I did some experiments with various desoldering methods. In this video, I'm going to focus exclusively on using Desolder Wick, and I'll be doing all my experiments on this board here, which is a board from an atomizer, a broken atomizer, because it has a lot of these capacitors, which are the same size, and so they will have pads of the same size. So I'll be testing things like using flux versus no flux, and perhaps the size of the tip, the soldering iron tip, what difference it makes if it's a big size tip or a small size. And I'll think of other stuff, maybe also before desoldering, maybe applying fresh solder versus not applying fresh solder, and to see which one works best. Let's get to it. The solder wick or braid that I'll be using is 2 mm in width, and it does not have flux in it. And I'll be using some also generic flux, all these bought from AliExpress. Alright, let's get to it. So this here is the capacitor we're going to start with, and if we flip the board, so it will be this point and this point. The first test is flux versus no flux. So I'm going to try removing or desoldering this point without using flux, and then I'll use flux on this one. I'm going to set my temperature to 350 degrees Celsius, which is the temperature I usually use, with a big tip. So let me turn on the soldering iron, and I'm going to set it to 350. There we go. Let's see. Okay, now I'm going to do the same with this point here, but I'm going to add some flux to my solder wick. Let me cut off that piece, and I'm going to put some flux directly on the braid. Alright, let's see whether this goes better. Let me do a quick cleanup. and then we can inspect the two paths. Okay, let's inspect. Let me turn on the other light. It might be actually a bit clearer. Let me see here. Yeah, let's turn this one on. Okay, let me turn this one on. Yeah, I think this will show us perhaps a bit better because there's less glare. So this is the first one without flux. Let me point to it. It's this one right here. Let me try and remove. Maybe. Okay. So I would say it did a decent job. I would have thought it would be much worse than this without using flux. But that's a decent job, not the best. And now the one with the flux, yeah, you can immediately see the difference. Let me see if I add a bit more light. Okay. I think you can immediately see the difference. Here you can almost see the gap, the gap of the via. And so probably with a little more desoldering, I could probably remove this pin without much trouble. Let's look at the other side of this. Let me add a bit more light. Yeah. Yeah, so it's stuck on that one side. It's still a bit stuck on this side, but on the other side it's quite done. If I put the solder braid on here on this side and suck this out, I think the pin will be free. Whereas once again the one where I didn't use flux, you see it's pretty much still covered all around on all sides. So for me it's clear that using flux is superior. I mean, that's the way to go basically. You must use flux. Okay, so that was test number one. Next, what should we test next? Next, let's test the tip size. Okay, so we're going to start with the same tip that I used in the first part, which is a bevel tip. I think it's like a C4, I believe. So I'm going to use the C4. I'm going to put flux on the solder wick, and I'll show you which two pads we're going to do next. I'll be using flux on both the small tip and the big tip, just to see the difference. Alright, so the next two sets of pads we're going to do are this right here and this. So I'll use the big tip on the right hand side and the smaller tip on the left hand side. Let's begin with the right hand side, which is this one. And to give you an idea of the size of the C4, let me go to the camera. So this is the tip of the C4, and the other one I'll be using is I think this is a probably C2 or 1. You can see the difference. Okay, so let's proceed. Alright, let's see how well this goes. So this is the big tip. Oh, sorry, went out of frame there for a bit. Okay. Let me turn off the door cleanup while it's still hot. Okay, so while I'm waiting for the soldering iron to cool down a bit, let's take a closer look at the results of using a big tip. And just like before, let me see if this is moving. Yeah, look, the pin is even moving. I hope you can see that. So that tells me this has been fully desoldered, the V I mean. You know, this is amazing. And let's look at the side view. This is one side. This is the other side. And this is me wiggling the leg. So that is simply a wonderful result. Alright, so I'm going to wait for the soldering iron to cool down so I can replace the big tip with the smaller tip, and then we'll be doing this pad next. Okay, so we're back. I've replaced the tip with the smaller one, so instead of a C4 we now have the C, I think it's 1.5 or maybe 2. Some flux on braid, sorry, door. Okay. Ready? Now let's see the yeah, okay. Okay, so now we're going to do this one. Let's see how this goes. This is going well also. Now I have to linger a little longer because the tip is a bit smaller. Let me do a bit more. So I have to keep my soldering iron on it tiny bit longer. But I think we're gonna get some good results also. Okay, clean the iron, tin it, and I'm gonna turn it off. Okay, let's see how well this went. Clean it quickly while it's hot. Oh, I see it moving also. This is a good result as well. I should mention that this is a single sided board, and let me measure how thick it is. It's not that thick. Because obviously if you're working with a thicker board you would want to use higher temperatures and bigger tips, because you'll be dealing with bigger pads and potentially bigger planes. So I lingered a bit too long here, and you can see a bit of the charring here. And the other one, yeah, the other one also has a tiny bit of charring. Anyway, let me see, is the pin moving on the second one? So this is the second one. And yeah, look at that, the pin is indeed moving. So actually, this capacitor, I could probably remove it. Huh? Look at that, it fell out. There we go. This is the capacitor. 223K 2JLS. 223,000 picofarad. I'm not sure what the standard is for these types of capacitors. But anyway, so let's look at the two videos. This is the one with the smaller tip. This is the one with the bigger tip. They look identical, obviously, so I mean. But all in all, I would tend to use a bigger tip than a smaller tip when dewicking, especially if you're dealing with like thick boards or pads that are on big planes, because they will sink heat faster. They will like suck the heat faster, which makes it harder to desolder. Let me see if I can quickly measure with a ruler how thick this board is. And obviously this is not, I have calipers, but for something like this it's not really. It's about one and a half millimeter. It's about 1.5 millimeters thick, so not very thick at all. But still, like I said, I would still go for the bigger tip than the smaller tip. Okay, so that's the second experiment. Let's move on to the third one. And the third one is going to be whether it helps to add fresh solder before desoldering. So far, I've been using the soldering iron at 350 degrees Celsius. For this experiment, I already turned it down to 270 degrees. So it's down from 350 to 270. And we're going to see whether it's best to add fresh solder before desoldering or not. Let me add some flux to the wick. Okay. And we're going to do the two low ones here. We're going to do this one and this one. First, we're going to do without adding fresh solder. Let's see how well that goes. I have kept the small tip, so the C2 or C1.5 tip. Okay, let's see how well this goes. Quickly up. We'll do the comparisons at the end. Now I'm going to add some fresh solder to this one and then wick it. This is fresh leaded solder. There we go. And you can see how shiny it is compared to the pads next to it. Alright, and let me cut the stem start here, use stars. Add fresh solder, fresh flux, and then plus the weight. There we go. Let's see if this goes better. Oh, I can see it lifting from the via. Oh, my microscope froze. I'll be back. Alright, let's continue. I'm afraid I have to put some more flux so that I can continue the experiment. All the other part got spent. Right. Okay. Yep. Okay, so let's see. Is this thing loose? Okay, it's in focus. This one is almost loose. It's barely holding on. Ah, there we go. See, just a little bit of pressure, and now you can see that it's actually moving. That's the one. That's the second one we did in this experiment, meaning the one we added fresh leaded solder to. The old one, the first one, where we didn't add fresh solder, is not looking too bad. Let me zoom down a bit. That's not looking too bad at all, in all honesty. Yeah, I mean you can clearly see that there is a gap there, but on the other side, there's still a lot of solder. Let me see if I use a tiny bit of force whether it will come loose. No, this one is holding on much stronger. But I must say that this is not too bad at all. But the one where we added fresh solder, it felt like it was wicking more. So I think the conclusion is, in a thin board like this one, and a small board at that, adding fresh solder is not really absolutely necessary. But again, if you're working on a bigger board, maybe a multi-layer board, bigger planes, depending on how big the pads are, it might benefit from adding fresh solder. But in this case, I don't think it was a major advantage. Should I do one more test with just temperatures? Like maybe contrast 250 degrees to 350 degrees. Let's do that. And now for the last test in this video, we're going to do 250 degrees Celsius versus 350. Same iron, same tip, same everything, just different temperature. And we're going to desolder this and then that. And I'm starting with the 250 degrees Celsius. Let's put some flux on the braid. We're going to begin with the one on the right, so this one here. At 250 degrees. Oh, I picked the wrong one. Did I? Yeah, I picked the wrong one. Alright, it's not too late. Let me restart. Wait. Go again. Take two. This one here. So at 250 degrees, it's working, but it's a bit. I would say it's slightly. There's a slight struggle, but it is working. Good enough. Alright, now we're gonna do this one. I'm gonna bump the temperature to 350. Let me do it now. 350. Prepare the braid. Add flux. Yep, sorry. There we go. Now you could see it, and I can feel it sucking the solder a bit easier with the higher temperature. There's less of a struggle. Hard to explain really, but yeah. Clean up. Alright, I bring the wax a bit down. Focus. Alright, so that's the first one we did, which is at 250 degrees. And it did a decent job. Obviously, I had to linger more with the iron. I had to keep the iron longer on the pad for it to suck up the solder. But it did a pretty good job. I mean, I can see a bit of a gap right there, so it's not bad. And the one where was at 350 degrees, yeah, and it was less of a struggle. You can see a bigger gap, and as I said, it's less of a struggle. It felt somehow easier with the higher temperature. So yeah, so once again, depending on how big your board is and how thick it is and how big the pad is, I would say you need to adjust your temperatures accordingly. So the three big variables, or the four variables, let me see if I can remember all of them. Basically, you have to put the right temperature, the right size, the iron soldering iron tip. It has to be big enough, and potentially add fresh solder. That one I'm not. I mean, I wouldn't say it's a critical part, but depending on what you're working with, it might help. And lastly, and probably one of the most important thing for desoldering, is the use of flux. So definitely, if your solder wick doesn't have flux, like mine, this one has no flux in it. You must use flux. It makes it much easier to wick. So anyway, I hope you enjoyed this video and found it useful, and see you on the next one. Bye bye.